4 years from now in India, you would have level 4 autonomous driving vehicles, and 5 to 6 years, maybe level 5 as well.
Thank you, Sanjeev, for being part of Change and Possible podcast. Really appreciate this you doing and being part of this conversation. So Sanjeev is the founder CEO at Swaayatt Robots. He is the recipient of 51 Most Impact Global Smart Leaders Award in 2019. He is also a recipient of Top 40 Under 40 Data Scientists in India, and he's been tirelessly working on enabling autonomous driving on Indian roads. Right. So I was in a company's website. So the mission states that you're making connected autonomous driving technology accessible, affordable, and available to everyone. Can you please elaborate on that?
Sure. So as you already know that there are like too many companies who are already working on autonomous driving.
Right.
Now, if you look at, for example, the biggest example is Google or Waymo or Uber, Tesla, right? So these companies are working on developing the technology that can work in a structured kind of traffic dynamics that you typically see in developed countries like in North America, Europe, and some of the developed countries in Asia and Australia as well. But these technologies may not directly work everywhere. For example, if you bring them into developing countries like in India, where the traffic dynamics is highly stochastic means it's highly noisy in nature, where you do not know what may happen at any given moment. So this is what we call stochastic in technical terms. So when the traffic dynamics is highly complex and stochastic, it's very difficult to make such a technology work. So this is the part about availability. When we talk about this is a part of making it robust so that it can work anywhere. When we talk about the other important factors, the cost of the technology itself. So if you look at the autonomous vehicles or the technology that is being developed by such companies, you look that they focus on mounting too many sensors on autonomous vehicles, right? So as you keep on mounting sensors, the cost of the vehicle is also going to go up.
Right.
And one of the important factors is that can you do more with less, right? So we are working on developing algorithms that can enable autonomous vehicles to perceive with as little sensors as required. For example, if you notice, all our autonomous driving vehicles had no lidars or radars. So we have been using only the cameras for processing the information, the sensor information. And we have been working on developing real-time low compute algorithms. For example, if you look at almost all these industries, they are developing algorithms that are highly complex. I mean, they use a lot of computational power. So we are working on making algorithms that use as less computational power as possible. And the third most important factor is that the technology that is being developed outside India or by any other companies for that matter, they depend very heavily on the available infrastructure. So, for example, all these companies depend on what we call high fidelity maps of the environment. So, high fidelity maps are, dense 3D representation of the environment. They are very detailed representation of the environment. So, before an autonomous vehicle can navigate in a particular area, the entire area has to be mapped. And the model works like this. The vehicle has to know where it is on planet Earth with, very high precision. Let's suppose with sub-meter error. So you would want the vehicle to localize with that accuracy. To be able to achieve that, you need to run some algorithms that cannot run in real time using the entire computational power that is available on board inside a vehicle. And that's where you need internet connectivity so that you can send the information back to a server, and server can do some computations that sends some information back to the vehicle. It's a 60 or 90 pose vector. We call it pose vector, which has X, Y, Z, yaw, pitch, roll, and other information. So using this kind of processing, the vehicle exactly knows where it is on planet Earth, and then the maps that you have built, they are projected on top of the vehicles. The information that you have received, and this is how you know where the vehicle is, and then you can take all the other decisions. Now, this is one particular field or one particular area that we directly attack. So we make autonomous vehicles independent of the available infrastructure by getting rid this dependency on the high fidelity maps for autonomous driving. So this is what we mean by making it accessible, affordable, and available to everyone.
I mean, yeah, obviously there are other players also working on using SD maps. So let's get into that later. So Is India ready for autonomous cars? But that's a big question, right? I mean, at this point in time, we've not even tackled electric vehicles. That seems to be a distant dream, right? Nitin Gadkari, the transport minister, had claimed maybe a couple of years back that his vision is to get India at least by 2030 complete electric. We are nowhere close to something like that, though that seems to be should be the most logical way to going forward, because we've done enough of environmental damage with ICE vehicles, right? So let's go. So do you think it's feasible for us to have autonomous before having electric vehicles? Because at this point in time, if you see, like you said, the biggest problem in India is the population and the traffic dynamics, right? Here we have people who are from rickshaws putting their hands out, giving a left signal and right signal, right? There are people who don't use rear view mirrors. There are people who just jump lanes. There are people who jump signals, right? So there is. I mean, I can go on and on with of the Indian roads. Tell me, where do you stand when you say, do you have the technology to start dealing with that first?
Sure. So first, one of your important questions is India ready for autonomous driving? Now, you also have to look at the problem from a sector point of view. Is India ready for autonomous driving from military or defense point of view? Definitely yes. Is India ready for autonomous vehicles from agriculture point of view? Now, I do not know what the unit economics is, but the feasibility from the technology point of view, yes, India is ready for it. If you look at it, is India ready for highway autonomous driving? For example, for autonomous, autonomous trucks and other, transportation vehicles? The answer is yes, but with some research element to it, right? Now, if you ask, is India ready for autonomous driving in core city kind of traffic at peak traffic hours? The answer is India is still, few years away from achieving that, because a research has to take place to actually achieve, let's say, level 4 or level 5 autonomous driving technology in these kind of traffic dynamics, and that's where we are headed, right? So as far as we are concerned, we have already achieved, I say, level 3 and 3.5, somewhere around there we are, and currently we are researching towards enabling SA level 4 and level 5. Now, some of the situations you have already mentioned, that okay, someone can just jump on the road, someone can just give a signal with their hand, and you have to take so many things into account. And this is exactly what I pointed you in the first place, that if you just assume that the way the autonomous driving technology is being built outside India, if the question is, are we ready for that tech? The answer is that tech just wouldn't work, because there are so many assumptions in the technology. If you want something to work in India, you have to get rid of those assumptions. And the moment you start getting rid of those assumptions, the traffic dynamics becomes more and more complex and more stochastic in nature. And this is one area with which we are dealing with. So we have been working on various, this highly mathematical problem, right? We are working on several branches of mathematics just to tackle this problem. And one of the, frameworks we are working on is, what we call multi-agent, where an agent is any obstacle or any other vehicle or any pedestrian on road, and we are trying to model the behavior of almost each of the agent on the road. So we are working on something as multi-agent intent analysis, where we try to understand the intent as to what the other agent is trying to do, and the negotiation framework, like how do we negotiate with that agent.
I'm sorry, are these simulations?
So we have tested, so we have developed the algorithms and we have tested in real world. So we have done all our experiments in Bhopal. One of the most ambitious experiment we conducted was on November 15, 2017, which is roughly 2.5 years earlier. So we have been working simulations as well. So all these technologies that I'm talking about, we have been working both in simulation as well as in real world, environmental scenarios as well. EV is a different branch of research, and autonomous driving, so they can go in parallel with each other. And by the time we are ready with EV, we shouldn't wait for autonomous driving technology to be matured, right? Because if we wait for that, a lot of companies from abroad will will come in India, it would be very hard to fight with them at that point in time, because even if we look at the current scenario, we are actually we are currently a bootstrap startup, right? And every company whom we are against, I mean, they are multi-billion-dollar companies, right? With many of those companies, we are actually in talks with collaboration. Some of the companies, not many of the companies, and we look them as a collaborator, not necessarily as a competitor. So we want to compete with some companies, and with some companies we want to collaborate as well, right? But the technology shouldn't wait, right? Because you can keep on doing research, and the technology has multiple use cases. For example, just to give you an idea, autonomous driving is a very complex problem. Now you may let's consider a very radical future, right, where everyone in the world agrees that there is no necessity of autonomous passenger vehicles, right? But why is it so important to develop this tech nonetheless, right? Because when you develop a technology that can deal with this level of stochasticity, this level of uncertainty, you can take the same tech and apply different areas as well, right? For example, a very good example is DeepMind. So DeepMind, if you follow the AlphaGo and all the other developments by DeepMind, those same tech they are applying for medical imaging. They are applying the same tech for several different applications as well. So the moment autonomous driving just happens to be one of the most complex problems of AI of the current decade and the decade that is about to come. And we can solve this problem. We are going to develop several different algorithms with several different use cases. Now, one of the definitive use case of autonomous driving tech in India is autonomous industrial vehicles, Industry 4.0, because in Industry 4.0 concept, you need several vehicles, you need different kind of automations, you need different transportation vehicles. We have been, looking into applications of our tech in autonomous shipping port vehicles as well. We have been, the same tech can be applied without, with just one area. I mean, when you talk about drones, drone also need algorithms that can process the information very fast. Drone also needs planning algorithms. And one more aspect of drone is that it would need, very sophisticated control algorithms, right? So the same tech that you're developing for autonomous driving, it can be useful for drone applications as well. And as I see, one of the most prominent applications of the tech right now in India is in defense. And due to the situation of our country, we are surrounded by many adversaries. It makes all the more sense actually to get into tech earlier than later actually.
So, Sanjeev, I'm completely with you when you say that tech shouldn't wait. In fact, I'm completely up for innovation. This podcast was built with the ethos to kind of take to people that the fourth industrial revolution is at the point where it's gonna just come up and slap your face exactly like COVID-19 did, right? So yes, you need to be better prepared. So really, cheers to you and your team. What you've been doing. So let me just get back to your website. Says you are developing SAE level 4 and level 5 autonomous driving technology. Now I know of this guy George Hotz, obviously about Comma.ai.
Yes. Yes.
So he's what he's building is exactly what you've been doing, retrofitting, with your normal vehicles with autonomous capabilities.
Sure.
Now he is saying level 4, level 5 is still way too distant. He's got a level 3 system that he's built. You've been claiming that you're working on level 4, level 5 autonomous. Please enlighten me more on that.
Sure. There's a reason to it why he says it's far, far, far away. George Hotz is, I cannot speak against anyone, right? I don't even like to speak against anyone, but just since you mentioned Comma.ai. So Comma.ai had been working on enabling autonomous driving technology via what we call end-to-end deep learning. It is just never going to work. Mm-hmm. And even in that, they didn't use what we call reinforcement learning. So just let me just, briefly describe you the area of AI, if I may. Right.
Yes,
so
please.
AI, as we know, all is nothing but applied mathematics, right? Applied mathematics, you have different, one of the most popular branches of AI is machine learning. And machine learning is further subdivided into several different branches of, so one of the most prominent branches is neural networks. And that has given rise to the field known as deep learning. Right, and what we call today is deep neural networks. Likewise, there are different fields, graphical models. Now, one of the areas of machine learning which helps in sequential decision making. Right. So, what happens in machine learning? You try to learn some function that matches the input data to the target output. Right, and if you can provide labels, maybe there's supervised, unsupervised learning, but I won't go into that as of now. So, in simplest sense, you have a data. Now, with that data, you try to learn a function that matches the input to the desired output. So this is what machine learning is. Now, there's a branch of machine learning which is known as reinforcement learning. So it is useful in the temporal task where you have to make a sequential decision. So what happens in reinforcement learning? The robot or the agent is in a state, some state. From that state, you take some action based on all the actions that are available to you, and you make a transition to a next state. And that next state, when you make a transition to that, the environment gives you a reward signal. And then through these reward signals, you actually learn a good or bad policy or an optimal policy for a certain behavior, right? For example, it is used in robotics very heavily. For sequential decision making. So one of the what I noticed about George Haas and his claims to autonomy is that they were trying to work. They were trying to develop the entire autonomous driving technology. They're assuming that the vehicle can be controlled by a single deep neural network framework. And this is never going to happen, because if you try to do that, then you would have to show your vehicle almost every given scenario that it can encounter, any corner case scenario over and over again, maybe 100,000 times every scenario. And how many scenarios can you actually show to a vehicle? And that's why his claim also says that you need trillion miles before you can actually demo any practical autonomous driving. And this is why his model is not going to work, and that is why I think the Comma.ai shut down their autonomous driving division, if I'm not wrong. I mean, they are currently working on ADAS, right? I mean, there is not a single company who is actually trying to work on the same model. I mean, we can show you the kind of autonomous driving that George Haas is trying to achieve in a day, right? You come here, we'll try to collect lots and lots of data with our vehicle, and within a day, our vehicle would be able to, run in a campus in an end-to-end fashion, right? But the moment you try to take your vehicle outside with any situation that it has never seen before, it will not be able to react to that situation. Now, one of the intelligent ways to actually build is maybe you can use reinforcement, where you show, some of the cases and the vehicle, tries to build on that representation that is being built as a result of using the reinforcement. So one of the companies who is using RL, there are almost every company who is working on autonomous driving has to use RL at some point. Right, but one of the very good examples is Wave.ai, WAYVE, if I remember. Wave.ai is a UK-based company. They're already, they have raised, several $1 million in funding as well. So their claim is actually mapless navigation using end-to-end reinforcement learning, right? But I read only a few of the papers that are available on their website, through their website, but I do not know whether they are trying to work in pure end-to-end fashion. So what happens is that you try to use deep learning. If you want to really solve the autonomous driving problem, you use all these components, all these tools, the deep learning, deep reinforcement, or any different branch of AI. You try to use them as a tool to solve a particular subtask. But you cannot say, okay, I will just build a super deep network framework and I'll try to show it every example that I can and hope that it will try to accommodate to every situation. It will try to learn an action given any situation that the vehicle may encounter in its path. It's very naive way to begin autonomous driving. Maybe one day, maybe 30, 40 years from now, when we have that kind of data and that kind of compute resource to build a really large, neural network with the use of reinforcement learning, not without the use of reinforcement learning. Maybe then, yes, if you have a simulator as well, when the vehicle can, simulate different kinds of traffic situations, and there's intelligent search algorithms that you also use to actually try to find out what are the corner cases the vehicle has not seen yet, and you can precisely focus in those segments, those corner cases, then perhaps yes, but not right now. You have to be more intelligent than just putting an end-to-end deep learning in your vehicle and hoping it would run. Okay. But again, it's nothing against George Haas, just it's pure technical explanation as to sort of what he's trying to do and how it should be done.
Lovely. So yes, I think there are people in different part of the world at this point of time experimenting with or push driving this conversation of building autonomous vehicle, right? And yes, everybody's got their own solution. So cheers to you. And I'm extremely proud that there's this Indian who is push driving this the ecosystem. So tell me, what makes Swaayatt autonomous driving vehicle different? So run me through the entire thing. What are the components behind and what are you doing? Because at this point in time, if you see, GitHub is full of open source code. And people are collaborating. First question, is that the way forward? Which I personally believe that's the way forward, because I guess with any technology, because all of these technologies are growing so exponentially, and if you don't collaborate, you do it building it in silos, you're not going to kind of like match up to the others, right? So is open source the way to go, and what makes Swaayatt robots different? What are you guys doing to build?
Sure. So regarding open source, so I definitely see at one point in future, maybe it would be too near in future, maybe 5, 6, or 7 years down the line, you may be able to download some of the autonomous driving modules, just like you download any software in computer vision or deep learning. Maybe you have a library that actually gives you all the different functionalities. You have a robot, you mount a camera and lidar in a particular position, and that's one of the goals with one of the Japanese firms released what they call AutoWare, right? So with AutoWare, they have this open source sort of autonomous driving platform where anyone can contribute to, and you can use it actually if you mount the sensors specific to their I have not used it much, so I cannot elaborate more on that, but based on my knowledge, whatever I have gathered is that it's one of the open source autonomous driving platform. Now definitely, I mean, that would be the way to go in near future, but currently it's a very you also have to remember that autonomous driving is very it requires huge amount of finance, right? And to have that kind of motivation keep on going, so I mean, it would require some company to actually bring this tech to some sort of a stable state where the open source community can use that and build upon it, right? Otherwise, this is a very R&D problem. It's very R&D in nature as of now, and open source works only for projects where you just have to commit code. Mostly what need to be coded so that you can build a library or build a software out of it, right? But this is a very R&D in nature. I mean, it's a very I mean, there are so many different problems in autonomous driving that many companies or even research labs have not solved, right? Now I'll give you a few examples as to like what we are doing right now as compared to every other. Why do we say that we are we are going to be able to compete with all these companies, right? Now if you remember first point that I mentioned, right, the competition cost of the algorithms. So autonomous driving has three major important technical pillars. These are perception, like after you sense the data from a sensor, you need to process it to build a 3D semantic representation of the world around you. Second is localization, as to like once you have the sensory information, how do you localize your vehicle on planet Earth so that you can project some of the information that you have mapped previously, right? The third area is planning, which is what is going to differentiate companies from level 3 to level 4 to level 5. So planning anything that is related to the decision making or the behavior of the vehicle on the road. All such algorithms are categorized and we call them as planning algorithms. It can be motion planning, decision making, any kind of decision making or planning that goes into a vehicle is categorized under the area of planning. Now let's talk about perception. So one of the things that you would notice is that Swaayatt robots has world's fastest algorithms for processing the sensory information. So why so because I have been researching in this area for the past 11 years now. I started my research when I was in my 4th semester of undergrad. So most of my research was in the area of planning. After coming back to India, like in 2014, we realized, okay, I started my company with just $60,000, right? I mean, in 2014, you couldn't even afford a lidar in $60,000. The cost of a lidar was $75,000 without, adding the import duty, right? So now you have a problem. You need to solve autonomous driving, but you have a challenge in terms of sensor, right? So now I had expertise only in the area of planning. And we took it. I took it as an experiment. Okay, fine. Let's develop the tech. Use the existing perception algorithms that are being developed by all the other research labs and companies all over the world. And can we use those algorithms to actually process the data from the images and solve the perception problem for autonomous driving? But that's the first thing we realized. Right. None of the algorithms that are developed by the state-of-the-art research labs, they don't work in Indian environments and they don't work in real time, right? So this was a challenge. So we started building some very key algorithmic architectures that can process the image that you receive from cameras in real time. And in 2016 December, we got a breakthrough. So I developed what we call deep geometric network. It's our semantic segmentation framework. The demo of this framework is on our website. There are 3 or 4 different videos. So it's our general purpose semantic segmentation framework. Or what semantic segmentation means is that every pixel in the image should have some label. So you need to compute the label of every pixel in image, and this is very computationally expensive task.
Right.
So typically companies spend around hundreds of gigaflops. One gigaflop means 1 billion floating point computations, right? So hundreds of gigaflops you need to spend actually to be able to semantically segment an image. I developed an algorithm that does it in just 12.47 gigaflops.
Wow.
Right? So that's our USP. Right. And likewise, the idea that was developed behind deep geometry network, that idea was propagated to almost every algorithmic framework that we have developed. Now, let me present you some numbers. Yeah. Obstacle detection, where you have to detect what are the obstacles surrounding the vehicle. The most heavily used algorithm in the industry as well is YOLO or mask RCNN, right? Mm-hmm. Mask RCNN does 600 gigaflops, right? The usable version of this YOLO does 140 gigaflop. We just published an entire network that does only 15 gigaflops to semantically segment the image for road detection as well as for obstacle detection. So now you can compare 15 gigaflop to 140 or 600 gigaflop. So this is where we have achieved the computational efficiency, and that's why we know that our algorithms are going to be consuming very less amount of energy as compared to any other competitor. And just to let you know, we are in very high level talks with some of the major OEMs. I cannot name those OEMs right now. But there are 3 major OEMs with whom we are currently in talks into deploying this software. So this has been verified even at the OEM level that yes, we have developed something that no other player in the market has. Right. We have, if I knew that this discussion is going to be that technical, then I would have forwarded our pitch deck before we began this conversation. So there in our pitch deck, we compare our results to NVIDIA. Now mind that NVIDIA is tens of billions of dollars company. We are just a bootstrap startup, right? So this is our USP in perception. So we have in perception area, we research in developing deep learning and computation algorithms that our research focuses in 3 things. One is that we want to research and come up with novel cost functions to be able to train our deep neural network framework so that they generalize better with lesser amount of data. Second is we try to come up with novel compute units that you will not find in any other research paper in open scientific literature. That has what our deep geometry network is. It has novel compute unit that allows us to semantically segment an image at 12.47 gigaflops. The third is we try to compute novel architectures that generalize well with lesser data and are also compute less compute intensive, so that they can support our cost function as well as our novel compute units in our architecture. So this is what makes us different when we compare the perception tech. If we talk about planning, I mean, if you remember the Uber's accident in 2018, I mean, there were several assumptions that the companies are making that, okay, that pedestrians are going to be driving in this fashion. Now, without naming names, I am under NDA obligation with several OEMs right now, right, to not disclose. So I cannot disclose their name, but I have been talking to few major OEMs. I will not even disclose their location as whether they're in Europe or North America. But just to let you know, even for ADAS, they are not using probabilistic representation of the environment. Right? Probabilistic means, okay, you are uncertain about a certain, for example, if you divide the area around an autonomous vehicle in grid, meaning 2x2 graph, I mean, where each of the grid is some location, some XY location in the environment around the vehicle, they are using deterministic representation to represent this grid around the vehicle. We call it occupancy grid, right? So this is what is happening in the autonomous driving industry, right? And a lot of assumptions are being made that the pedestrians are going to walk in this fashion, the vehicles are going to drive in this fashion, they're going to follow lanes. If you look at some of the most prominent startups in US, Zoox, right? So this is the company we are not in NDA with, so I can tell their name as well, Zoox. If you look at their video, was it put online in 2019 or 2018, you would see that merging in a highway intersection was considered a very challenging problem, right?
Right.
If you look at, so I mean, we are in for a startup, so our vehicle looks very, not very that pristine actually. I mean, it's a very mechanical, I mean, raw in nature actually. So we did this demo in 2017, November 15, where our vehicle just had 15 centimeter margin on either side. To negotiate a dynamic bike that is coming its way, and our vehicle navigated through that region without even, maybe you can, after this conversation, maybe you can see that video and put it somewhere so that your audience can see as to what I'm talking about. So vehicle actually navigated through this region without even stopping for the bike to pass. So these are the kind of challenges we are dealing with without even realizing that this is being considered as a state of the art by the industry at large, right? So we don't make any assumptions about the traffic dynamics, and some of the algorithmic frameworks that we are currently working on developing, they actually directly tackle this highly stochastic traffic dynamics. So I have been researching now why we have developed so many algorithms in planning area. I've been researching in this area for the past 11 years. And for the past 4 years, I've been working full time. So my areas of research were reinforcement learning and motion planning in particular. And we have developed some motion planning algorithm that can sort of plan very high speed plans to navigate through a region that is considered, I mean, that would be considered almost impossible by any other autonomous driving company. I mean, I can give you an example. This happened during an interview with one of the major OEMs. I mean, you can count them on fingers. I mean, the top 4-5 OEMs, right? What I proposed them, they said it is impossible. What you just said, it is impossible. I described them mathematically how it can be done, and then they had to agree that whatever I was telling was correct, right? I proposed that our motion planning algorithm could actually generate results at 2000 hertz, right? It means it would take just 500 microseconds to come up with an alternate plan if something bad happens in the environment around it. And 500 microseconds seems very less, right? And that's where the question was, like, how can you do that? I had to explain them all the linear algebraic computations that we are doing actually to achieve that. So some of the things are highly mathematical in nature. I do not know what to speak about. For example, we are working, I mean, one of our most prominent motion planning algorithm, it uses 7 different reinforcement learning agents that evaluate all the different kind of parameters that ensure the safety of the vehicle and its environment, right? There are some of the reinforcement learning frameworks that we have developed that uses we are also using the concept of what we call as homotopy, right? So just to briefly elaborate to you what homotopy means, let's suppose if I give you 2 different sets, and those sets contain some objects, let's say, right, or some elements, right? If I can prove to you that these 2 sets are homotopic, right, mathematically, if I prove to you that these 2 sets are homotopic, it means if you compute the property of all the elements in set A, then you automatically get the property of elements in set B. So we have been using the concept of homotopy to actually scale our multi-agent intent analysis and negotiation framework so that the computational cost of the system can also be checked when you scale it up to 100 different agents in the vicinity of the vehicle. Because if there are 100 different vehicles surrounding your vehicle, then you have to monitor the behavior of almost every vehicle, and you have to compute the safe trajectory, safe behavior against almost every other vehicle, every other agent in your surrounding, and the competition are going to grow exponentially, right, if you don't have if you don't use some specific mathematical tricks. So we have been working in the area of manifold theory. We have been working in topological theory to actually extract some of these mathematical ideas. Maybe these are some things that make us different from all the other companies, because I have had a chance to actually present this idea and talk about it for 6 hours continuously with one of the very high-level executive of one of the very big companies in some area, right? I wouldn't name names because it wouldn't be good. And that executive told me that what you're working on, I don't think even the companies in US are working on. And just to let you know, this executive, these kind of executive regularly interact with Elon Musk, John Krafik, and all the other big figures in the autonomous driving industry. John Krafik is the CEO of Waymo. So we can only get feedback. So I can only present our tech, what mathematical ideas we have worked on. We are using game theory, several any imaginable area of computer science and applied mathematics. Not so much in mathematics, because I wouldn't claim, because I don't have a PhD in mathematics, but almost every imaginable area of AI that you've ever heard of, we are using all of those things to actually make this tech, the planning tech, all the more robust. And we can only speak about our tech. Let's suppose if you had interacted before this meeting with John Graphic, then you would be able to compare our tech against what Waymo has. Right? So the same thing goes with us. We can only present our tech to these executives, to these companies, and based on their feedback, when we get the feedback from them, the ideas that we have worked on, we thought these are the ideas that almost everyone has worked on. But it turned out that no one actually even thought about those ideas. Let me present you one more problem statement. It's related to perception, right? One of the very challenging problems in the area of perception is to be able to detect delimiters in the environment. What are delimiters? Easiest to understand delimiters are road boundaries, lane markers. These are some easiest to understand delimiters. There are some salient delimiters in the environment. What do I mean by salient delimiter? Let me give you an example. Let's say you have a traffic sign. It's mounted on a vertical pole. The base of the pole where it meets the road, that forms a salient delimiters. If you can detect these kind of delimiters, you can build a much more contextual and semantic representation of the world around you. Now, many companies often find it very difficult to detect these delimiters in real time. In India, as you would know, these delimiters are sometimes even non-existent on road. For example, you would find roads, there are no lane markers. So I started this research way back in 2016 December, after developing deep geometric network, which was semantic simulation framework. And rather than just detecting delimiters, our system can even predict delimiters if they are not present on the road. So this research has led to the development of our lane detection generation algorithm. It's one of the most unique lane detection generation algorithm. You wouldn't even find such a demo even on the NVIDIA's website. I mean, all the companies, they can detect lane markers if they're present on road. Our system can generate them ideally where they should have been if they're absent on road. So these are some of the ideas that we have worked on actually that make us different from all the other companies. And I haven't even talked about localization. Now, this is very debatable area, right? I mean, sometime I have to admit to my peers as well, yes, it is required because of some of the scenarios they present, right? Mostly from a financial and lawsuit point of view, right? For example, what if your vehicle crashes with someone else and there's a lawsuit, right? So it's better to be safe than be sorry later, right? So this is why mapping is so extensively used in this industry, to have that additional degree of or additional information layer that you wouldn't have otherwise. So this is how autonomous driving industry worked, and this idea was pioneered by Google, right, way back in 2009 and 10 when they began their autonomous driving research. So this idea, before autonomous driving vehicle navigates in a region, the map should be available. And when the vehicle navigates again through a region, again you get all the sensory information, you send it back to the cloud. The cloud does some computation and gives you some pose vector that tells you where your vehicle is on planet Earth. Then the map that you have built, you project that information on top of the location of the vehicle, and this is how you know very precisely on what lane you are navigating, how much is that particular intersection away from you. So this is a model of autonomous driving. Now, why do you have to do that, right? Why do you have to use map? There are several reasons, right? But one of the most prominent reasons is that you cannot reliably detect delimiters in the environment in real time, right? It's so hard to do it, right? Can you almost always guarantee that I'd always be able to detect the boundary of footpath with 100% accuracy? Almost always, right? So this is Waymo's or Google's model of autonomous driving, or almost every other company has adopted it. Human way of autonomous driving. Let me ask you a very simple question. When you navigate from your home to office, do you know where you are on planet Earth with 1 meter accuracy without using any GPS or spatial sensor?
Obviously not.
Right? But still you are able to drive.
Yeah.
Right? Why so? Because you are very good at localizing yourself with respect to the surrounding, with respect to the local delimiters in your environment. And this is the same concept where we are working on. And just to let you know, so all these three, perception, planning, and location, they may seem very different areas from each other, but they are all communicating with each other in an autonomous driving vehicle. So earlier I told you about an area, delimiters prediction. This area combined with our sophisticated planning algorithm that can deal with very high levels of stochasticity in the traffic dynamics, when you combine these two, you can get rid of the maps. Right, because you're so good at localizing yourself with respect to local surrounding, and
you don't need the maps.
Yes, and your planning algorithms are very robust at dealing with uncertainties.
Right.
And that's how we get rid of this high definition mapping of the environment. But from a technical point of view, yes, we can also do high fidelity maps. You can generate high fidelity maps. In fact, we are currently working on one of the areas is to generate high definition maps of the environment, so that we are also can pitch the software to some of the industries, maybe in campus driving and industrial autonomous driving, and for autonomous driving as well, if our customer demand that, right? Along with that, we can do high definition maps now. So the companies like Mobileye and NVIDIA have demoed with sparse maps. We can also generate sparse maps using typical, algorithms that are available in the visual odometry or SLAM literature, the scientific literature. In 2013, when I was a grad student at University of Alberta in Canada, I started. One of my papers had been rejected several times. More than 2 or 3 times, right? And one of the challenge, one of my advisors asked me, like, can't you prove that this algorithm is going to converge to the end goal and location no matter what happens? So I was working on algorithms that enable autonomous vehicles to navigate without having any map of the environment, right? They don't even know what obstacles they're going to encounter. This has nothing to do with my MS thesis or my master's degree. I was working independently on this idea since I was a second year undergrad. And so that's when I started researching on. The name is also mathematical. It's called as overlapping convex polyhedrons for mapping the environment, right? So what it means, in a nutshell, what it does actually. So it does this. In typical mapping, you build the 3D structure of the environment as it is, right? So you have the sensory data, you fuse the sensory data, then you compute the temporal relation between the data that you captured time t and time t plus 1 and so on, and you build the map of the environment. So the map exactly looks like a 3D representation of the environment. Now, what if there is a mathematical function that can reproduce this 3D structure without requiring you to store the 3D structure, right? Additionally, it should have one more property, that it requires very less computation, right? So this is the idea behind overlapping convex polyhedral maps. So instead of storing the 3D structure of the environment as it is, we store some of the mathematical properties of the environment. So the environment is represented using polyhedrons, right? These are polyhedrons, right? And the way to inference, if you want to inference against the typical maps, you'd have to run an algorithm. In a simplistic form, you would have to run an ICP, iterative closest point algorithm. You won't run an ICP. You would run a very modified version of an ICP, but still you'll run some form of ICP to know where you are. Now, this is very, very complicated algorithm. It's a highly non-real time. You would require a GPU to run it in real time. Whereas our mapping framework would just perform some linear algebraic computations, and all our laptops, if you are using Ubuntu and all these operating systems, they come with highly efficient linear algebraic computation libraries known as LPAC and BLAS. And you can use these libraries to actually perform those linear algebraic computations in very computationally efficient fashion, right? So this is, even if we talk about let's suppose, we can get rid of maps. We can just use GPS maps for navigation. But even in the worst case scenario, if we have to use maps, there also we have innovated something, right? And since being a bootstrap startup, we cannot test every idea in real world. So this convex polyhedron based mapping we have tested only in simulation, and this is one of the least researched area in our startup. So the most important area in our startup is planning. The second most important area, for which we have the most number of demos on our website, is perception, right? So sometimes it gives an idea to the viewer that the area we are researching in is perception, but it is not the case. Perception is our secondary research area. And our third and final research area, which is least important to us, is localization. right? Planning, why don't we have as many demos in planning as compared to perception? Because planning demos are, they would be mostly in simulation, they would be in projected space, and it doesn't look good. Right. I mean, we have built a simulator that's very mathematical in nature. It will just give us some numbers, and we can infer those numbers and know what is happening in the system. But it's not graphical in nature, so we don't have much demos on our website pertaining to perception. But one of the most prominent demos that we have is November 15, 2017 demo, where you can see the tight space through which our vehicle navigated.
Thank you, first of all, for sharing all the details, the years of work that's been put through, and I see that you guys are so resilient, because I mean, even when like you said, you started, there was some $60,000 you started with, right? But you had a desire, and that's the reason it's 11 years down the line, and whatever you're doing, I mean, I think you're doing excellently well for a bootstrap startup. I wish the listeners who are listening in, investors who understand that there is great things happening in India. You don't need to look outside. You don't need to look at Tesla. You don't need to just look at Waymo and others. I mean, the investors need to look at India. There are some startups who are doing wonderful things, and you are definitely one of them. And I'm extremely happy to have this conversation with you, because I do believe that India lacks tech companies, these tech behemoths. Somehow we have some of the best leaders from here are all exported abroad, right? I mean, you Google, Microsoft, you have these CEOs who are Indian, but we don't have an Indian global company. And I wish you the very best, and I hope that you create something big and make us proud. So I had seen a couple of videos, and I thought maybe I could be completely wrong, right? So I thought that maybe your vehicles was swaying and maybe possibly not sticking to the lane. I could be completely wrong, right? So, but autonomous vehicles, at least a level 3 autonomous vehicle, is sticks to a lane. That's the basic. So tell me if I was wrong, and what are the efforts that you are bringing in to push forth to level 4 or level 5 autonomy, or is level 5 autonomous even possible?
Sure. I think one of the demos that you are talking about, where the vehicle was appearing to be a bit swaying, I think we were recording the video from the side. We have only 2 highway demos on our website. So in one, what happened, like we were recording, so there was another vehicle, a Chevrolet, in which our team was, right? So they were recording, and that vehicle was coming too close to our vehicle. Right. So our vehicle was thinking that, okay, that this vehicle is trying to switch the lane. And that's where our vehicle actually swayed a little bit. It slowed down as well as it swayed a little bit. So that gives an appearance to the audience that, okay, that the vehicle is swaying. But if you look at if you look at the Zee Hindustan demo, when there was only one instance where the vehicle was slow. The cameraman actually came too close to the vehicle, and the vehicle reduced its speed. But the moment the cameraman actually moved, so cameraman was on a bike, so the moment they moved away from the vehicle, the vehicle actually sped up, right? So that one demo that you're talking about, where we are recording from the side, the vehicle actually was coming too close, and that was a reason why, I mean, the vehicle was swaying. And also one of the reasons, like, we are not able to demo our technology in its entirety. Why do we have so less demo? Because you can see the condition of a vehicle. So there are different levels of noises that we are dealing in the system, right? So definitely there is uncertainty in the environment. Along with that, all our motors and anything that we have mounted, any sensor that we have mounted on our vehicle, these are not industrial grade sensors that you'd see in an autonomous driving vehicle. If you look at it, there is a one night demo which we're doing in a campus. And I was talking a lot about as to what we are trying to achieve in this demo, right? And we are trying to achieve the right motor speed so that it can actually perform the turns at higher speed, because we are dealing with regular, 4,000, 5,000 or, 10,000 rupees a stepper motor that are actually not made to do this task. So there is a lot of, component level sort of limitations that we are actually dealing with. And our vehicle, I mean, you would see that after September 2018, we have not done a single vehicle demo, because our vehicle is not in a mechanically fit situation to actually keep on continuing doing demo with it. And that is why we are now entirely focused on taking our technology frontier even further. right? So most of the demo right now are all technical in nature. They are all either developing, showing some new perception algorithm, or we are focused on demoing the capabilities of our planning algorithms via simulation. Because one of the OEMs with which we are actually going to work with, they have asked us actually to work in simulation, right? So we are going to focus on simulation even more from now than earlier, right? So this is the reason why we are not able to demo the full strengths of our technology. And in some cases, if you see our earlier demos, our steering was very shaky, very noisy in nature, right? Why? I mean, you never encounter such kind of problem with any other company because they have a perfect vehicle, right? So in our vehicle, if you rotate the steering, it will take the effect on the tire after some delay, right? So the controller is actually working back and forth to actually adjust it at the right position so that the vehicle can run smoothly. So this mechanical limitation has actually created all those jittering in the steering, as well as the reason why we are not able to demo the full strengths of our technology.
Right. So besides you guys, there are these other guys who are like Flux Auto being one of them, who's then Pinaki Laskar from Fisheye Box. I think doing something similar in nature. So are you guys building an ecosystem where you're collaborating, reaching out together, and how's been the investment space, for the autonomous vehicle sector?
So as far as when the questions concerning the other startups, I mean, I think you can interview them and you can know about them, what they are working on. I don't have much of an opinion because for me for example, if you ask me about Waymo, right. I would look at their demo, what they are doing, right? If you ask me about NVIDIA, I would look at NVIDIA demo and I would go through their papers, right? So all the other startups, although there are some good startups like Atimotor, they are doing some research. Then there are like High-Tech Robotics, maybe doing something similar. Then there's like Gironj Robotics, who are working in the area of the industrial robots and other different areas, right? But when you talk about other autonomous driving startups who are claiming autonomous driving, right? One of the things lacking is that they are not able to present the novel thing that they are doing, right? For example, if I today take an algorithm from an internet and if I put it on my vehicle and open source software, how would you know what am I doing in autonomous driving, right? If I disclose, so there may be restriction from a patent point of view. For example, we have also not filed patent, but at least we are disclosing the gigaflops. As to how much computational efficient we are and the capabilities of our algorithm as to in what kind of scenarios they work in. So I don't see this kind of information from any other side, not even Atimotors, right? Now why can I speak about Atimotors? Because Saurabh Chandra is a good, I mean, we have spoken many times, right? But still, I would like to see the demo first before commenting on anyone. Just like when you asked about question about Comma.ai, I know their goal. Their goal is to put an end-to-end deep learning framework. So I can extensively talk about that tech, that whether it is going to work or not. So I would have to know that information first as to what algorithms they have developed, whether they have developed any new algorithm in perception and planning or not. If that is not the case, right? If that is not the case, if they're not doing an R&D, it's not so wise to claim that you're working autonomous driving because you are actually not, right? I mean, this technology is far away from downloading a deep learning library and putting data through it and saying solve. The technology is not that mature. It's a R&D problem even today not just for us, even for Waymo. It's an R&D problem, right? So this problem is very complex. And even, for example, when we are very open to admit we have not solved every problem in the area of perception. We have solved very key problems that enabled us to make the LiDAR redundant. And only when we achieved that level, we started claiming now we have a tech that can actually get rid of LiDARs in vehicles. But even today, we admit, if you add radar, the representation of the environment would be all the more robust, right? So you have to know your capabilities, you have to know what you're doing, and you also have to know your limitation before making any claim.
If and when your technology is completely ready, what would be the price points? Would it be a retrofit kit model? Would you be developing autonomous vehicles? What is your solution? What is your vision going forward?
So there are some things that are confidential in nature, like because we are talking to so many players, right? But yes, I mean the tech. We are working on both models, B2B and B2C, right?
Right.
Now B2C is relatively far away, because to achieve B2C, you have to ensure, you have to gain, you have to prove that all your mechanical components, whatever you're retrofitting, they certified maybe some IP rating 67, whatever the rating is, right? Some ISO certification, right? So that's why retrofitting is secondary aspect, although it goes well with ADAS system, right? Where ADAS is advanced drivers. So for ADAS, yes, retrofit and OEM integration are both okay for us. But when it is concerned with autonomous driving, we are primarily focused in directly with OEM integration, right? And the fleet owners like Uber, all the other. I mean, in fact, we see Waymo as a collaborator, right? Just to let you know. Even I try to reach out to Elon Musk also through Twitter, right? Although unsuccessfully so far, but because we see there's a lot of similarity. I mean, many companies are developing algorithms that can, for example, let me present you a broader perspective, right? All these companies have developed a pipeline where their vehicles are already navigating, right? But what is the reason why no company is able to put their vehicle on the road for passenger applications, saying, okay, we don't need driver from today? It's because they don't have the level of sophistication that is required in planning algorithms to deal with any kind of situation. And maybe that is the area where we can help them, right? So even though we didn't give a full autonomous driving tech from planning, perception, localization point of view, we were just able to share some algorithms to help them actually accelerate their autonomous driving, and we are able to generate revenue in a shared revenue model as a result. So this is also one of the models that we are looking at. From ADAS point of view, we are okay so mostly now what is stopping us from actually taking our technology to market is the funding, right? So I mean, we now with one of the OEMs, you see, I mean, it would be released soon, that we have collaborated with one of the major European OEMs. It got slowed due to coronavirus. I mean, so that has been one of the factors. But yes, we are slowly, going to get there. And from funding point of view, I mean, Indian VC system is like, very sort of. I mean, I don't know. I mean, it's we don't expect that we would be getting funding from an Indian VC firm, right? We expect either it can come from an OEM, maybe in India or abroad, but mostly either a foreign VC firm or a foreign OEM, because it takes a lot of vision actually to invest in this kind of tech. And currently, I feel that Indian VC system is slightly lacking that vision, because they feel, I mean, there's this point, okay, where is this tech going to be applied? Who is going to buy it, right? The market already exists. You have to understand that, because all these OEMs have already built an ecosystem where the vehicles are navigating. Now, we never said that this technology is specific to India only. We are building a tech that is tested in India. And there's a huge difference. If you are building a tech only for India, then the question is, okay, why would a company in North America would want to buy it? But we are not saying that the tech is intended for India only. We are saying that tech is tested in India, because only when you test and certify your technology works in this kind of traffic dynamics, that is when you can certify that it will work anywhere else as well. And case in point is Bosch. If you remember, the very recent news from Bosch is that they started, they have a plan to test their autonomous braking system in Indian traffic. Right? Why? Because you will not find this kind of stochasticity. No matter how many models you build, you'll never be able to, capture the uncertainties in those kind of models. And that is where we are also, headed. We want to use this Indian environment as a benchmark, sort of to say, okay, this is where you have to test to actually certify that it is going to work in any kind of scenarios.
So Sanjeev, tell me, do you think this technology is going to be driven forward because of the natural disaster of COVID-19 today?
Sure, I definitely think so, because now people, earlier, I mean, if you look at people, they were asking questions like why this tech is useful. I mean, from Indian context point of view, I mean, many people ask why this technology is needed in India. And this is why it is needed in India to deal with these kind of situations. For example, I just give you some examples where it can be potentially useful. I mean, definitely, for example, you see the industrial growth has become stagnant because of non-availability of the workers, right? And this is where you need automation. You need Industry 4.0 automation. You need delivery vehicles that can, be helpful in context. So nobody thought that this kind of pandemic can even occur.
Right? Yeah.
But it has happened, right? And this kind of tech is going to help you in contingency planning, right? This can be potentially useful for delivering supplies to military into armed forces. This can also be helpful to police for patrolling, for autonomous patrolling, because you just cannot put police force on patrol 24/7. So that's where this vehicle can be used. Also in drones, because in drones one of the most important factor is the power consumptions. I mean, and if you can develop algorithms that can reduce the power consumption on board overall, then you would have much more flying time, right? And so there are several use cases. And now I think with this pandemic, the world will, I mean, in US and other countries, they've already realized the potential of this tech. There are robotics companies and autonomous vehicle companies who are being used for contactless delivery. Maybe India will also at some point see the potential of this tech.
Lovely. Yeah. So yes, I really hope and I wish that all VCs over here, instead of running for those immediate ROIs, understand that the future is coming really fast. Technology is growing exponentially, and autonomous vehicle is going to be playing a huge role in the future of mobility. The one who has a foresight and a vision will become a billionaire. And so it's the choice that one makes, right? So yes, and you also mentioned that the Indian traffic roads, right? If you can build a vehicle which can handle the Indian roads,
sure,
or the Chinese road, it can handle anywhere in the world, right? So one last question, right? Because your website claims that you guys are working on level 4 and level 5 autonomous vehicle. Do you see that possible, level 5? I mean, if yes, what is the timeline that you see?
4 years from now in India, you would have level 4 autonomous driving vehicles, and 5 to 6 years, maybe level 5 as well.
Lovely. I'll hold you for that. I'll catch you again 5-6 years, and we'll definitely have a conversation. And definitely in the middle, I will try to open up my conversation with my friends and make connects, because I think you're doing a brilliant job. So all the very best, Sanjeev. It was a pleasure talking to you and sharing information. And to my listeners, if you like what you see, please press the subscribe button. Like always, I'm going to leave behind all the details of Mr. Sanjeev down below, so that you can reach out and interact, because this is about building a community and reaching out and growing the ecosystem and putting India in the world map. And Sanjeev is already on his way to put or build a company which is going to go on the world map. So all the best, and thank you for being part of the show.